Okay, today starts a new chapter. We'll be doing 3 lessons in chapter 15 this week. So our first lesson today deals with square roots and finding square roots. Okay, so some important information we need to start with. That one thing you need to know is that squaring a number and finding the square root are what we call inverse operations. They're inverse operations. So if I take 2 squared equals 4, and then the square root of 4 equals 2. So basically they work hand in hand. Another thing you need to know is something called a perfect square. A perfect square has a factor that can be multiplied by itself to equal that number. And there are several perfect squares that it would be definitely in your best interest to memorize, okay? So these are our perfect squares for our factors 1 through 15, all right? So let's look at our first perfect square, 1. 1 is a perfect square because 1 times 1 equals 1. 4 is a perfect square because 2 times 2 equals 4. So why do you think 9 is a perfect square? Because 3 times 3 equals 9. So, and it keeps going. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And obviously you're probably catching on to the pattern by now. 7 times 7 is 49. And then we have our 8s for 64. Our 9s for 81. Our 10s for 100, 11s for 121, 12s for 144, 13s, 14s, and then 15s end at 225. So if you can memorize that not only these numbers are your perfect squares, but what the square root of these numbers would be. And the square root of these numbers is basically the factor that's multiplied by itself. All right, so let's write these square roots underneath the perfect squares. This is going to save you a lot of work because you're not allowed to use your calculators as you move up into Algebra 1 and geometry and you're taking your dual enrollment test. You're not allowed to use your calculators to find square roots and cube roots. So you either need to have it memorized or you need a method that you can use by hand to find a square root. And I'm going to teach you that today. All right, so we're just kind of drawing a line of separation, and underneath we're writing our square roots. All right, and obviously you're going to see a pretty consistent pattern here. 9, 10, 11, 12, 13, 14, and 15. And again, memorizing this will save you a lot of time and hassle. So let's talk about the radical, okay? This radical is positive unless there is another sign in front of it, like your negative or your positive and negative sign. So we know that the radical now defines our answer as either positive or negative. All right, and you'll see that in the examples in a minute. Okay, so in example 1, it's important that we pay attention to the directions here. It says find the square roots, plural, of a perfect square. And the reason there's more than one perfect or more than one square root is because there is no radical, okay? It's just the number that stands alone. So we know that the square root of 49 is what? All right, we just talked about it. It's 7, okay? Because 7 times 7 is 49. The reason there's more than one square root is because negative 7 times negative 7 is also positive 49. So you're not going to have to show this work on a quiz or a test, but you will have to make sure that you put in this symbol, positive negative 7, because your answer is both positive and negative when there is no radical in your original problem and it's just the number by itself. All right, so 121. Find the square roots. Well, it's going to be positive negative 11 for the same reason that we just explored over here, because negative 11 times negative 11 is still 121. All right, so I'm not going to be necessarily looking for any work to be shown on those problems. All right, but it is important that you are not using a calculator. Even though you don't have to show work, you either have it memorized or you do have to show work, okay? Which, again, I'm going to show you in this lesson how to show work if you don't know the square root of a number. Okay, so now what we see different in example 2 is we see radicals, okay? We see the square root symbols. And because of that, our answer is not automatically positive negative, okay? Remember what we said in the instructions. The square root symbol is positive. So if that's all we see here, then I know the square root of 25 is 5. Now, obviously, what we see different in the second problem is the negative sign in front of 49. So that simply means take the square root of 49, which is 7, and then your answer is negative 7. All right, for the last one, we see a positive negative symbol. So it's just important that when we're taking these square roots, that we're also bringing in the sign that was in front of the original radical, which in this case it would be positive negative 4. All right, so when there's radicals in your original problem, that defines the sign of your answer. So now let's look at example 3. Here we have fractions, but the convenient part, and this is not always the case in Algebra 1, you're going to find all kinds of crazy numbers, okay? But in this lesson, the convenient thing is that numerator and denominator will be perfect squares. So what's happening when you take the square root of a fraction is you're taking the square root of the numerator and denominator. Now, this can be helpful if, say, the numerator is a perfect square but not the denominator. Okay, so now we just simply take the square root of 9, which is 3, and the square root of 16, which is 4. And as long as this fraction cannot be reduced, that would be my final answer, is 3 over 4. Okay, so now let's look at the second problem. All right, now we see a positive negative, so we just have to make sure that that's in our answer. And we just remember this means the square root of 36 over the square root of 81. Okay, so the square root of 36 is 6, and the square root of 81 is 9. Now, before we try to make this our final answer, we're missing a few things. First one is I need to make sure that this is completely reduced. Is it reduced? No. So I need to reduce it to 2/3. And I must remember the sign that was in front of the original radical. Okay, and that's the positive negative. 2/3. Okay, last one. Again, this means the square root of numerator and denominator. So the square root of 1 is 1, and 100 is 10. The only other thing I need to remember is the original sign in front of the radical. Okay, so just put that in your answer, and you are good to go. All right, now we're going to start kind of putting together some of what we learned so far. And now there's some operations that we need to take care of: addition, subtraction, possibly some multiplication. In this first problem, we see 5 times the square root of 36 plus 7. I know this is multiplication because there's no other sign in between the 5 and the radical. Okay, so this means 5 times 6 plus 7. And we know that order of operations tells us to multiply first. So 5 times 6 is 30, plus 7 is 37. Okay, so we're using our rules for radicals and square roots to solve. Let's go to the next one down. We have 1/4 plus the square root of 18 over 2. Well, what I just told you in the last example was that numerator and denominator would be perfect squares, and that's great. Well, the problem here is that 18 is not a perfect square. So before I try to take the square root, let's look at what 18 divided by 2 is. Okay, well, what is 18 divided by 2? It's 9. So now I have 1/4 plus 9. And we know that 1/4 plus 9 equals 9 1/4. Okay? All right, so now let's come over here. All right, and there's two ways to solve this. When it comes down to your quiz and your test, it's not going to matter either way, but I am going to show you if you can recognize, and this was in our first slide, the inverse operations, that squaring a number and taking the square root of a number actually cancel each other out. So if you ever see the square root of a number turning around and right away or immediately being squared, those operations actually undo each other. They cancel each other out. Taking the square root of a number that you're about to square, they cancel out, and your answer is just 81. But let's say you don't catch that. Let's say you forget about that rule. Okay, well, take the square root of 81. What is the square root of 81? It's 9, and then you bring down the squared. What's 9 squared? You're going to find that it's 81. But if you can catch those inverse operations, you don't have to do any of this work. Okay, so again, that's not work I'm going to require you to show, because I'm hoping that you catch the inverse operations and you save yourself a little bit of work. All right, so this last problem, really the only place you can run into issues is if you forget order of operations, okay? So we don't do 12 minus 3 first. Even though that's left to right, we don't want to do that first. We want to say 12 minus 3 times 5, because 5 is the square root of 25. And 12 minus 15 is negative 3. So just be careful to follow order of operations. If you do that, you should be fine. Okay, so now we get to solving equations with square roots. When we're solving equations with square roots, it's very similar to solving equations in general. You have to get the variable by itself on one side. Well, that involves inverse operations, right? So if there's multiplication, I divide. If there's addition, I subtract. Well, in this case, we have an exponent of 2 that we have to get rid of. So that's where that inverse operation can help us. So if I have an x that's squared, I can take the square root of that to just get x. But if I take the square root of one side, I also have to take the square root of the other side. So x equals 9. But now the question comes back into play that I saw at the beginning of this lesson. Yes, 9 times 9 equals 81. But what about negative 9 times negative 9? Doesn't that also equal 81? Yes, that is true. So because positive 9 can be plugged in here, and negative 9 can also be plugged in, my answer is positive and negative 9. Okay, so your rule of thumb is when you're taking the square root to solve an equation, both the positive and the negative version of the answer is acceptable. Okay, all right, let's look at this next one down. All right, now the square root is something we want to do last. If I tried to take the square root now, I have to take the square root of the 3 and the 48. So the first thing I'm going to do is try to move everything to the other side of the equation. Well, if there's multiplication attached, I know I need to divide. And what's really nice about most of these problems is that once I divide and I bring down my a squared, what's 48 divided by 3? Should get 16. Now that is a perfect square. So when I take the square root of both sides to get a by itself, I actually end up with a whole number, positive and negative 4. All right, so I just want to pause here for a second. Just go ahead and pause the video. I want you to try to work these two problems ahead of me. Okay, so did you take the square root of both sides? And did you make it k equals 13? And again, if you had 169 memorized, then you just knew that it was positive negative 13, and you're good to go. If you didn't, the next example I'm going to show you how to find the square root by hand. Okay, now the last problem, it's a two-step. We know that we need to do our addition and subtraction first. 4b squared equals 196. Now I divide both sides by 4. Remember that square root comes last. B squared equals 49. Square root B equals positive negative 7. All right, so solving equations. You'll have a couple problems like this on your homework and your quiz and your test. Okay, so what happens if you're asked to find the square root and it's a really large number, or maybe it's not a large number, but you just completely forgot, you're just blanking out, you don't know what the square root is going to be. Like I said, the calculator is not going to be an option for you in the classes that you have coming up, and especially on your dual enrollment test, you won't have that calculator to just punch in the number. So the way you do it is by using a method called upside down division. Now, this is something that you probably learned in 6th grade, at least last time I checked, they were still teaching it. But upside down division is basically an upside down division sign. But here's the main rule. You have to divide by prime numbers outside the division sign. So just as a review about prime numbers, and you're really going to stick to these 5 numbers. You very rarely, if ever, would be outside this this range. 1 is not prime. 2, 3, 5, 7, 11. You can write those down. These are the numbers that you'll be dividing by to do your upside down division. You must divide by prime numbers. You say, well, I know that 10 goes into it, or 20, or some other number. It won't work unless you divide by prime numbers. So I want you to start with the smallest prime number that you know goes into it. If you don't get it, it doesn't mean you'll get it wrong. It just makes it harder to do step 2. So for 625, I know that 5 is a prime number that's divisible. Okay, so now I'm going to divide 625 divided by 5. Okay, and I get 125. Okay, well, I know that's divisible by 5. And I get 25. Looks like lots of 5s. Okay, and as soon as there's a prime number, meaning there's no other factors except this number and 1, I know that I'm done. So you say, how in the world is this helping me find the square root? Well, my rule says if I'm finding the square root, I'm looking for a number multiplied by itself 2 times. So I want you to look for groups of 2 common prime factors, and that will count as one group. So because it's square root, it's going to be 5 times 5, which is 2 5s, counts as a group, and I have another group of 5s. So one group of 5s and another group of 5s, you're going to multiply them, and 25 is your square root. Okay, so you'll have, this won't be on your homework assignment, but it will be on your quiz. You'll have a question where I will specifically say use upside down division to find the square root, and that's how you would do it, okay? So you're going to find those groups of 2 prime factors and circle them. Okay, so let's look at 400. I want you to think of a prime number that is divisible, the smallest one possible. All right, hopefully you're thinking 2. Divide it, and you get 200. 2 again, and you get 100. 2 again, 50. 2, 25, 5, and 5. All right, so now let's go back and circle our pairs of 2. Remember, it's pairs of 2 because it's square root. So 2, 2, and 5. And for each pair, 2 times 2 times 5, I'm going to multiply each pair. 2 times 2 is 4. 4 times 5 is 20. So 20 is the square root of 400. Okay, and that will be everything that you need to know for section 15.1.